Okay, we stopped here yesterday. Now we continue with the example. There's quite a lot of calculation that you need to do. Okay, if the given infos are, the components are many, okay, so you need to calculate a lot. Now, okay, we go from the statement. Make it bigger. Okay, a distillation column operating at 14 bar, saturated liquid. Okay, saturated liquid feed of 1000 kmol per hour with composition given in the table is to be separated into an overhead product that recovers 99% of the N-butane overhead. Okay, 95% of I-pentane in the bottoms. Relative volatilities are given. Okay, so you have here a saturated liquid with the feed 1000 kmol per hour. Overhead is your N-butane. So distillate, this is your distillate. Light key. Top product light key. Okay. And then 95% of I-pentane in the bottoms. So bottom, so this is heavy key. Okay. Now from the component over here, they give a lot of component in the feed. Mixtures of component. So you need to identify which one is your LK and HK. Here it mentioned. Okay, from here it already labeled for you. And butane as low key distillate. I-pentane is your bottom heavy key. Okay. Okay, now this is the feed for each component and relative volatility. Okay. Then it distribute the component in distillate and bottom. So this is the value in distillate. Di means distillate. B is bottom. This is the feed of each component. Sorry, not feed. Mole rate. Okay. In distillate, this one is in bottom. This one, mole fraction. Okay, X is the mole fraction. D means distillate. Okay, this is mole fraction distillate. This one is mole fraction for bottom. Okay, how to get the mole fraction? If it is not given, how do you want to calculate the mole fraction? How you can get this value? 0.1089 in distillate. Okay? Correct. Okay. This one is 3 distillate value over the total value. Okay, then you get the fraction. Yeah, so this one is the DI over D total. DI over D total. Then you get the XID. Same goes for the mole fraction for bottom. bottom and and pentane over here, the mole per hour in the bottom over the total mole. Then you'll get the fraction. Okay, in the distillate, why there is no N-hexane, N-heptane, and octane? And pentane is only a few. Why less of this thing? Less for distillate. Why? For the distillate column. Correct. I just want to know whether you understand or not. Why this part is less? Because they are heavy key. So that's why they are less in the distillate. Okay, we don't simply put the figure over here. Then this part and pentane, you will see there are more in the bottom product. Sorry, N-pentane. Up from N-pentane to N-octane, there are more in the bottom product because they are heavy key. Okay, so all of these should be heavy key. Sorry, bottom product, not heavy key, bottom product. Heavy key is the required product. One is bottom. So the top one is the top product. Okay, up to that? Can to get the fraction of the distillate and the bottom. This one you will need in order to calculate the minimum reflux. Okay, here the question asks you to find minimum reflux ratio. R min. R min. Okay. Can So I move to the next slide. Okay. This is the Underwood equation, where you need to find the R min. But in order to get the R min, you need to find the theta first, the root. Where does theta come from? From this equation. Once you get the theta, then you input in the Underwood equation. Okay, they are related. These equations are related. Now, first step is to find the theta from this equation. Okay, then second step, now the crucial part is to find the theta. Because if you don't get the correct theta, your R min will be wrong. Now, how to get the theta? From this equation, you will need the relative volatility on top part over here, multiply the XIF. What is that? Just now XID and XIB. Now XIF. Feed. Mole fraction of the feed. Okay. XIF is mole fraction of the feed. Now you need to get the info of the mole fraction. Just now it is not given. So you should calculate the mole fraction of feed. Okay, from the given value just now. Okay. Then find out the total of alpha multiplied by XIF. So each of it multiplied by the relative volatility, then you'll get the total. Now in this equation, you have Q. What is the value of your Q? Yes, correct. So your feed condition is saturated liquid, right? From the previous slide, it mentioned it is saturated liquid. So if saturated liquid, 1 or 0? Okay. Here, if saturated liquid, it should be 1, the Q. Yeah, Q here. If saturated liquid, Q is 1. Okay, so input 1 into the equation. Here is 1 because of saturated liquid, the Q. Q equals to 1 because saturated liquid. Okay, 1 minus 1 is 0. The right side is 0. So we should find the value of theta so that the summation is equals to 0. Remember, the equation over here is summation. Okay, here, summation. So summation of all values, this part over this part should equals to 0. Okay. Now, for theta, we need to do try and error, the value. You see here, that's why it has few values. Okay, I explain first, later we try to do the exercise. Now, you can put any values of the theta. How to select the value of theta? You check the relative volatility value of the light key and heavy key. Okay, here is light key and heavy key. Relative value 9 and 5. Okay, 9.04 and 5.74. So your theta must be in between that value. Theta value you can select between these two values. So that's why you see over here, the try and error, the value, here it shows you 7, 7.3, 7.2, and 7.2487. This one to show you when it is closer to 0. Sorry. Okay, the summation, the total should be 0 over here. Okay, I explain how to use the theta. Let's say you assume your theta is 7. Okay, we take this one, 7. Plug in the theta value into this equation. Into this equation. Okay, that's why you see over here, it used this equation. Okay, so plug in the value of the theta into this equation. Then do the calculation. check out the total value. Okay, the total value must be closer to 0. Because why? Because just now 1 minus 1 equals to 0 from here. So we must find closer to 0. The summation of the value over here must be closer to 0. Closer to 0, or if you can get 0, should be excellent. 0 value. Okay. So once you get the total approaching 0 or 0, so that is your theta, the one that you should use in the equation. So this theta is the one you should use in the Underwood equation. So here we'll go to this. Yes. Sorry, can you what? No, the relative volatility is given, and we just straight away use the value. It should be given. Relative volatility will be given. Because it is based on the properties of the component. Relative volatility over the heavy key. Over heavy key means the mole or what? Relative volatility over the mole of heavy key. Equation, the K value, everything, right? Usually it will be given. Okay, relative volatility, most of the time it will be given. So for this equation, for this question, straight away you use it and find the alpha, relative volatility multiplied by the mole fraction of the fit. Then the summation should be approaching 0 by using the trial and error value of theta. How to get the theta value? Between the, it must be between heavy key and light key, relative volatility. Okay. Not it must be, but that one is the best prediction between the heavy key between the heavy key and light key over here. Okay, the value of theta. Because if you simply take the number along of this value, you will take some times to get the total approaching zero. Okay, so we minimize the error, we minimize the time. The theta value just take between the light key and heavy key. Okay, any question before I move to the next step? This one you want to find the theta first. Okay, 5 minutes for you to digest. Then I proceed to the next step to find the Armin. Okay, 3 minutes now. Now, next, move to the next step to find the Armin. Once you obtain your theta, we need to put into this equation. Okay. For Armin, you need this value. Alpha multiplied by the XD. Okay, the XD just now you have calculated or given from the previous slide. Okay, so XD, relative volatility, you have it here. Then multiply both of these. Okay, now for this part, insert the data that you obtained earlier into the equation for all the components. Then you will get this value. Okay, this is not the final value yet. This is equivalent to R min plus 1. Okay, the equation is R min plus 1. So this is R min plus 1. To find the R min, the value that you get, minus 1. This is your final answer, R min. Okay, any question? Any part that you need me to repeat? James, what are you looking at? Understand? How to get the Armin? Okay. Now we try one example. For example 2 in the slide, you can check on your own. I want you to practice on this part. This example. Wait, let me share the screen. Okay. Now this exercise, it gives you this component. Okay, 4 components. And it mentioned the light key is N-butane, heavy key is N-pentane. Okay. What happens if it doesn't mention the light key and heavy key? How do you want to assume? If it doesn't mention heavy key or light key, how you want to mention? Huh? Sorry? Relative volatility. How to know? Percentage recovery. Percentage recovery. Okay, here it mentioned recovery in distillate. Distillate, right? So the most recovered in distillate must be the top product. Okay, top product. This 2 is top product, but if it doesn't mention any of the light key, you can choose any because both in top product. Remember, light key is your main required product, not necessary to be the highest product in the distillate. Okay, light key. Again, I repeat, light key is your specific required product. Distillate, it can be many mixtures of products. Light key is your required specific product. Okay. So in this case, in this question, the light key, the required product is N-butane, not the propane, even though it is 100% recovered. Okay, so in this example, light key is the N-butane. Heavy key is the N-pentane. Now here it mentioned the recovery in distillate. It gives you only the infos of feed, relative volatility, recovery in distillate. From the Underwood equation, which you need to find the theta, you need the fraction of the feed a fraction of the fit. And to find the R min, you need fraction of the distillate. Okay, so these are the infos that you required. Now, we should find the theta, which we need Q value. Okay, assume saturated liquid. Okay, here I mentioned feed is saturated liquid. Okay, so Q equals to 1 or 0? 1. Saturated liquid. Okay, Q equals to 1. Now, we need to find the XF, fraction of the feed. How to get this fraction of the feed? How to get fraction of the feed for each component? Switching. How to get the fraction of the feed? How to calculate fraction of the feed? How? Sorry? Fraction of the feed? Come again? 300 divided by 45. Vice versa. 45 over 300. Fraction. 45 over 300. Then you get the fraction. The feed over total feed. Okay. Then from there, calculate for the rest. Make sure your total fraction is 1. If more than 1, then something wrong with your calculation. Okay, then calculate for the XF multiplied by the alpha. So this XF multiplied by the relative volatility. Okay, so here 0.15 multiply with 2.95. I show using Excel to make it faster. but you should know how to calculate using calculator. Okay. Let me know if I go too fast. Pressure, okay? Then how do you determine the theta value? Okay, theta value. So, as I mentioned earlier, the theta value take in between the light key and heavy key. In between this value. You can try any value. Here I try 0.65, 0.85, and 1.05. Okay, it depends how many theta value you want to do try and error. As long as you can get the total approaching 0. I remain as 3 over here to save the time. Okay, in the exam or midterm, just limit to 3. Okay, from the 3, you check which one is closer to 0. Yes, you can choose that as your answer. The theta.
Yeah, the total is, let's say the total is 0.1, 0.05, 0.02. The one that's 0.02 is the answer.
Yes, you can select that theta value that provide the total of that. Okay, so use that theta into the underhood equation. Okay, so let's say over here, I choose 0.65. The summation of this, the equation should be alpha multiplied by the xf. This part, this one. This value divide by alpha, which is this one, minus theta value 0.65. Okay, for this theta value, I put 0.85. Okay, you see the difference. Now, from these three, we take the one that is closer to 0, which is this one. Okay, even though it is not that close, but from these three selection, take the closer one, because you don't have time to do many values for the try and error. Choose 3, then from the 3 values, choose the total that is closer to 0. Okay, if you want to try further, if you have time, perhaps you can expand into 0.6 or 0.5 or 0.4. Okay, so we choose this value. Okay, let's say we change the value. Let's say we change the value to 0. We know 0.65 is closer to 0. Then let's say we change to 0.55. Wait. We just remain this 0.65. Okay, here 0.55, so that you can see the difference. Okay, and 0.5. 0.55 negative, 0.65 positive. So perhaps 0.6. Try 0.6. Okay, between these 3, which one is more closer to 0? Between these 3 values, which theta value that would you choose? Which one? Which one should you choose? Which one closer to 0? Damien, how about you? Which one is closer to 0? 0.6. Okay, so this one closer to 0, so choose this theta value to proceed for our mean. Okay, so again, it depends to the theta value that you choose. Always remember the theta value selection must be between the light key and heavy key relative volatility. Okay. Okay, now, okay, we choose this one better, 0.6. Okay, we choose 0.6. To input in our next step. Now, to calculate the R mean, you need XID, fraction of distillate. The distillate value is not given. How do you find the distillate? In order to find the fraction, you need the value first. How to find the distillate? Distillate value. How to find the distillate value? Fasil, how about you? How to find the distillate value? There's no info from the main table over here. How to get the distillate value? How about you, James? Yes, recovery time the feed. Here it mentioned recovery in the distillate. So the recovery percentage multiplied by the feed. Then you will get the distillate. Okay, so here the recovery 100% multiplied by the feed 45. Okay, same goes for the N-butane, N-pentane, and hexane for the rest. Okay, so here the distillate recovery multiplied by the feed. Sorry, not 100. 1. Okay, 45 multiplied by 1, the 100% lah. So in, out, 100%. What comes in, comes out. Okay, what goes in, comes out. Okay, then for the N-butane, the recovery would be 105 multiplied by 0.95. Okay, so this one would be 90 multiplied by 0.05. One is 0. Okay, this is the distillate rate, not yet the fraction. Distillate rate. To get the fraction, divide by the total. Okay, the fraction divide by the total. This one divide by total. Okay, then from there, the mole fraction of the distillate multiplied by the relative volatility. Now, theta just now we choose to as 0.6. Okay, so the theta should be 0.6. plug in into the equation. You will get, okay, this column, the summation of this column using theta 0.6. So this one, this value divide by the relative volatility minus the theta is 0.6. Okay, this is your R min plus 1. So your R min should be the value minus 1. Okay, take your time to digest this. Part that you need me to repeat. Yes. Midterm next. Midterm. We'll cover this topic. Midterm. Because midterm ClO2 and ClO3. This one is ClO3. Midterm. Separation train synthesis. So inclusive in this. 2, 3. 1, 2, 3. Part of chapter 1. Okay, this is not yet the final part. After you get the armin, there is another step where you will require the armin to calculate the vapor load. Okay. Okay, before we go to the vapor load, any question on this part before I move? Clear? Okay, we move to the slide. Back to the slide. This one you can try on your own. Example 2, please try on your own later on. Okay. Okay, just brief you through first because this one will require sometimes for the calculation. Okay, I explain first. Just now, once you calculated the R min, you will require the value in here to find the vapor load or the minimum vapor load. Okay, so that R min will be used in this equation. The vapor load, why you need to calculate? Because you will need to find the best sequence that has the lowest vapor load. Okay, so from here, the vapor load, input the R min value into the equation. You will get a few values of vapor load. Okay, this one depends on your sequence. Okay. Okay, this example, where just now from the R min, let's say from the R min, you get already the V min for each distillate. Vapor load, remember, vapor load is on the distillate part. Vapor, top product. Why we don't consider bottom? Bottom liquid. Okay. The volume clearly mentioned vapor load, vapor. So it's all top product. We consider only top product. Okay. Now from here, from this example, it has two sequence. Okay, from the R min calculated, you will calculate the V min. Okay, the V min from the equation just now, which is V min. I explained the flow only. This is not the continuing example, the flow. Okay. Now from the R min, you will get the V min for each distillate stream. From there, total up the V min for each sequence. Okay, so this is sequence 1. And this is sequence 1. This is sequence 2. So from here, total vapor load, minimum vapor load for each sequence you will get. Okay, so from there, compare which one is the minimum. From here, minimum is sequence number 1. So we can conclude sequence number 1 is the best sequence. Due to the low vapor load. Okay. Any question? Yes. We are running out of time. I think it is not enough time to show step by step. I explain the flow first. Okay. So for next class, which is on Tuesday. Tuesday we have class, right?
Yeah.
Wait, I'm not finished yet. Wait. I'm not finished yet. I'm not finished yet.